Hello, welcome. Today we are going to talk about how to ace questions on exponential and then logarithmic functions. So I've prepared this worksheet for you. It's in the description down there. I want you to download it and all of us will practice. Some of you might have heard it already in the past, so it's cool. Print it out and then let's all work on it, okay? All right, let's start with the first question. Before we start with the first question, please note that this is a past question, I think from 2016 all the way to 2020, if I'm not mistaken, so it's a lot, about 31 pages. So I will solve as many as I can and then the rest you should do it, okay? And then check the marking scheme for the answers, just to be sure. So the first question says that the function they have given us f of x, the domain is that it belongs to all real numbers. We should write down the range of this function. Well, if you look at it, an exponential function of this nature will behave like this. See, the 6 here means that the horizontal asymptote is at 6, so the function will behave like that. That means that the height of the function starts, all right, from this line, which is asymptotic, okay, and goes up to forever, okay? So you will say that f of x is greater than 6, okay? So that's it, f of x is greater than 6. Okay, for 1 mark. Then the next thing says that find the inverse of it. So you let y be equal to f of x. Okay, so if y is equal to f of x, then the next thing is that you write y is equal to 6 plus e to the power 4x. Okay, so from here, let me adjust the camera. All right, from here, next thing you want to do is to interchange the positions of x and y. I know some people like to just make x a subject. I like to interchange the positions of x and y. So I have x here, I have 6 plus e to the power 4y. Okay, and then I'll solve and make y the subject. So I'll move the 6 to the other side. All right, and then I'll take the length of both sides is equal to length this guy. Now, why did I put this in absolute sign? Because length can never be negative, so you want to put the answer there in an absolute sign, okay? So this will give you 4y is equal to length into bracket x minus 6, and then you divide 3 by 4, so y is equal to 1/4 length x minus 6. Okay, the next thing that we are interested in is that find out the domain. Now, the domain of the inverse, okay, it is the range of the function. Okay, so let's take that. So domain will be such that let me just say x is such that x is greater than 6. Okay, or if you want the domain, you can equate this, okay, send this thing to greater than 0. So you can just say that x minus 6 is greater than 0, so x is greater than 6. That's also another way to find the domain of a natural log. Now the next thing is for us to state the range.
Choose one answer.
Now the range of this function is the domain. Okay, the range of the inverse is the domain of the main function. Well, the domain of the main function is x belongs to all real numbers. That becomes the range of this particular inverse. So this function, the inverse, the range is such that it belongs to all real numbers. Okay, so that's one way to go about it. The next thing says differentiate the f of x. Well, if you haven't learned differentiation, I have a whole video on it. You can go to my playlist and you see the playlist on differentiation. learn from there and then apply the concept here, but I'll solve the question for those of you who already have knowledge on differentiation. So let's go and grab f of x as 6 plus e to the power 4x. So f of x is equal to 6 plus e to the power 4x. Now if you differentiate a constant, you get 0, so that 6 is 0. If you differentiate an exponential function, it remains as the exponential function, but you must also differentiate what? The power, and that is 4. So your answer is 4e to the power 4x. Okay, then the next thing that they want us to do is to find the exact solution when we equate the function to its what? Derivative. So we have 6 plus e to the power 4x is equal to 4e to the power 4x. Alright, so what I want you to do is that you should get rid of this guy. Let it come to the other side, alright? So we are going to get 6 is equal to 3e to the power 4x because it comes to subtract. Divide through by 3, so you're going to get e to the power 4x is equal to 2. Take the natural log of both sides, that gives you this is equal to ln 2. Alright, so you have 4x is equal to ln 2. So x is basically ln 2 over 4. Okay, so that's how to go about it. So they said the exact, okay, so you don't want to put this on the calculator, no. Leave it like that, alright, in ln form. The next thing is that we have a problem like this and we want to solve it. You can divide both sides by 5. It's a way to go, or you can just take the natural log of both sides. That's also fine. So if I divide both sides by 5, I'm going to get this is equal to 14 over 5. What is 14 over 5? Just in case I want to work in decimals. 14 over 5. That is 2.8. So just in case we want to write in decimal, we can write that, okay?
Yes,
so then we take the natural log of both sides.
Yes. Good. A number of roots. I think I told you.
Well, so we are going to get 3x plus 4 is equal to that 14 over 5. Okay. So 3x will give us the natural log of 14 over 5 minus 4. You divide through by 3, you are going to get natural log of 14 over 5 minus 4 over 3. Okay, so I'm going to leave my answer like that. But I mean, or I can also put it on the calculator. Since they didn't say that, leave it in the exact form, I can put it on the calculator. And then I'm going to get natural log of 14 over 5 minus 4 divided by 3, and that will give me x equals negative 0.990, 3 significant figures. Alright, then the next thing is that we have lots of log here, so this is a logarithmic equation. So you want to check the bases. It seems like they are all in base 10. Okay, that's good news. If it is not in base 10, let's say one of them is not in base 10, then we have to apply the concept of change of base. And then if we apply the concept on it, then we can solve more questions on it. And I think I have a video on that on the channel. You can check it out. Logarithmic video like that. So, well, this and that, you can see that they are adding. If they are adding, it means that we can use the multiplication rule and then combine the two together. So we are going to get log of y times this whole thing, okay, this y times that. So we can write 2y squared minus 7y, okay, is equal to the log of 3 squared. Why? Because this particular 2 has to go up, okay, so it comes to become the exponent of the 3 there. All right, so the next thing that we can do is that we write log of 2y squared plus, minus 7y is equal to the log of 9. Okay, so it doesn't necessarily cancel out, but in a loose sense we can say it cancels out, okay, so that we can comfortably write 2y squared minus 7y equals 9. And then we can write 2y squared minus 7y minus 9 equals 0. Okay, I'm just going to use my calculator to solve this. Since it's not really a quadratic, I believe you can solve a quadratic by now. All right, so 2, -7, -9. So I have y is equal to 9 over 2, or y equals -1. Okay, that's according to the calculator. The next thing is that you want to write this whole thing as a single log to base 2, okay, as a single log to base 2. All right, so let's start with the numerator. Well, if you check the numerator, they all have base 2, and it's subtracting, so that means we divide. So we have log p over q base 2, okay? Then divided by, we have this guy here. Now we want to be careful because this is base 2, this is base r. The question says write it in base 2. So now let's change this guy here to base what? To base 2. All right, so we have log r base 2. Now is multiplying. Let's change that to base 2. So log 2 base 2 divided by log r base 2. All right, now check this thing out. This is going to cancel out with that. Okay, so really you have log p over q base 2 divided by log, check this thing out. Log 2 base 2 is what? It's 1. So divided by 1, that means that your answer, anything divided by 1, is the same thing. So you can write this guy as your final answer. Okay? All right. So the next thing that we do is question number 5. It says, given that this is true, okay, and that is what we call assertion. Okay, they are giving us a claim that is p. So we should use this claim and then solve the other problems down there. Now they have given you log 4. Log into bracket 16x base 4, and you can apply the rule of logarithm here. When you open up the bracket, you have log 16 base 4 plus log x base 4, right? Now 16 is 4 squared, so you can write log 4 squared base 4 plus log x base 4, right? Then this 2 here goes back, okay? So if it comes here, then you have log 4 base 4, and log 4 base 4 is 1. So that means that you are left with 2 there, so you have 2. And then you have plus log x base 4. But what is log x base 4? According to the definition, that is called p. So we can write plus p. Okay, and we are done because they wanted us to write our answers in terms of p, so we are done. All right, the next thing that we have here is this friend of ours. So we can apply the division rule of logarithm. So you have log x to the power 7 base 4 minus log 256 base 4. Okay, now the 7 here will come back right down here. So we are going to have 7 log x base 4. Now think of 256. You see, it has a base 4. So try to see 4 raised to the power what will give you 256. I do not know that off my head, so I will just put it on calculator. I'll try 4 raised to the power 4. Yeah, 4 raised to the power 4. It is because I know 4 raised to the power 3 is about what? 80 something? I don't know. Let me check it out. Yeah, 64. So 4 raised to the power 4 is 256. So we can write log. I'm sorry. Have log 4 raised to the power 4 base 4. So you can write log this guy 4 minus 4 log 4 base 4. You know log 4 base 4 is 1. Therefore that part, this particular part will be left with 4. And then we also know that per the definition, okay, log s base 4 is p, so we can write 7p. So let's put everything together. So we have 7p minus 4, and then we're done. Okay. Now they are saying that using your answers in parts I and II, solve something like that. Okay, what is this first portion? Well, that portion is what we got as, let me use this color as this. Okay, so that is 2 plus p. So let's write it. Let me clean this thing first. So that is 2 plus p. How about this part? Log 7 to the power x to the power 7 over 256 base 4. What is it? Well, we got 7p minus 4 as the answer. Okay, so we can do that. So we have this guy minus 7p minus 4. Everything equals 5. Then we can solve. Okay, but remember, answers 2 decimal places. So you have 2 plus p minus 7p plus 4 equals 9. So we are going to get that's 6 minus 6p is equal to 5. So we can move that 6 minus 5 equals 6p. So we are going to get 1 is equal to 6p. Therefore, p is equal to 1 over 6. But what they want is not a fraction. They really want a decimal. So we put 1 over 6 on the calculator, and then we will get 1.72. Sorry, 0. That's wrong. The answer is 0.17. They wanted 2 decimal places, so that's what we gave them. All right. Okay, that's good. I think everything is intact. Yeah, that's fine. The next question here is 2 logarithmic equations, and they said that we should show that this happens. Well, how do we do that? I think we have to give it a try. One thing is that everything here is in terms of x. All right, so let's try and get rid of, and there are no logs here, so all the logs and the y's here, let's get rid of them, and see what happens. But we are going to get rid of them legitimately, okay, using all the rules that we remember. So from the first one, okay, let me call this equation 1 and then call this equation 2. So from the first one, we have log y plus 1 base 2 is equal to 3 minus 2 log x base 2. So we will have this guy here. I want to group all the logs, so I'll move it, so I'll get plus. Okay. All right, now I want to take this 2 here back, so to go and become an s squared. Okay, so I have log this guy base 2 plus log x squared base 2 is equal to 3. Now remember that when they are multiplying, they are adding, it means that if I make it a single log, they'll multiply. Okay, so I will have log x squared y plus x squared, or what, base 2, not base y, sorry, is equal to 3. We can also make this 3, write it in terms of log, so I will use log 2 base 2. I'm doing this because of this number here. All right, and then this 3 will also come back, so you have 2 raised to the power 3, which is 8. So I'm going to have log x squared y plus x squared base 2 is equal to log 8 base 2. All right, then the next thing that I'm going to do is that I'm saying that if this log and that log are the same, then this and that will also be the same. So I can now go and write x squared y plus x squared is equal to 8. All right. Okay, so you can leave this and call this maybe equation 1. I'm going to clean this work out, so you can pause the video at this stage, and then copy the solution. So I want to clean all of this. All right, and then get more space to work out with this. All right, then let's work from equation 2. So from equation 2, we have this 2 equals 2 plus log y base 2. I'll put the logs together. Is equal to 2. Now, remember that if you have the subtraction sign here, that means that the two logarithmic functions are dividing. Therefore, you are going to have log x plus 2 divided by y base 2 is equal to 2. Now, I'm going to write this as log 2 base 2. Then my next step is going to give me log x plus 2 over y base 2 is equal to log 4 base 2. So I can say that if this log and that log are the same, then this and that should also be the same. So I'm going to have x plus 2 over y is equal to 4. And I can write x plus 2 is equal to 4y. All right. Given this case, I can make y the subject, right? Divide both sides by 4. And then I'm going to get y to be equal to x plus 2 over 4. So I'm going to clean all of this. All right, let's clean all of that. And then we can also clean this guy. And then we will copy this and then bring it up here. And then we can clean this guy. Okay, so now we have two equations. Okay, let's solve it. Let's call this equation 2. So I'm going to put the second equation to the first one. So I'm going to have s squared x plus 2 over 4, and then I'll have plus s squared equals 8. Okay, so I'm going to have x cubed plus 2x squared over 4 plus s squared equals 8. I'm going to multiply 3 by 4. I'm going to have s cubed plus 2x squared plus 4x squared equals 8 times 4, that's 32, right? Yeah. So you have s cubed plus 6x squared minus 32 equals 0. Okay, and this is exactly what the question wanted us to get. Okay, so that's how to go about it. All right, for 4 marks, check it out. 4 marks, it's cool. Yeah, I was just cleaning, but you have a lot of space here to work out should a question like this come in exam room. This is actually a question that came in October, November 2020, last year paper. Okay. And they want you to find the roots of this equation for additional 4 marks. So this is about 4 marks. It's a cubic. I'm going to solve it using all the steps that exist in solving such a question. I want you to first grab your calculator, okay? And then you put the function on it, the equation, s cubed plus 6s squared minus 32, and then look for the positive and negative factors of 32. So I can put 1 there, and then you are just inputting those factors till you get 0. I'll put negative 1 there, I'll put 2 there. Yes, when x equals 2, this thing will give me, this function here will give me 0. So that means that x equals 2 is a factor. So the next thing I want to do is to move these 2 to the other side. So I'm going to have x minus 2 is equal to 0. So I'm going to use this factor in my calculation. Remember the long division? Yeah, I have a video on that. You can also check it on this channel. So you have s cubed plus 6x squared. You know there is no x term here, so make it 0x, then minus 32. All right, now let's start the division. These 2 would divide s cubed s squared times, right? So let's write the answer in red. and then you use this to multiply the answer here. So you get s black. So x cubed minus 2x squared, and then you subtract. Okay, when you subtract, you get 8x squared, and then drop this one down, so you have plus 0x. X will go into 8x squared, that's about 8x plus 8x. And then you use this 8x here to multiply everything here. So you are going to get 8x squared minus 2x. You subtract. So that will give you positive 2x. Drop the negative 32 down. And now x will go into positive 2x how many times? That's plus 2, right? Yeah. And then use this 2 here to multiply everything there. So you are going to get 2x. Let's see, if it's a factor, then why am I not seeing what I'm supposed to see? Let me see. Let me put 2 into it again. That's 0. So what happened? Let me cross check. I think I've made a mistake somewhere. Okay, this goes there, s squared. Use this to multiply, I have 2x over there. You subtract this minus that's 8. You drop this guy down 0. And then this goes there, 8x. You multiply, you have that 8x. Oh, okay, I found a mistake. This is supposed to be negative 16. Okay, negative 16x. All right, so let's clean here and there and write 16 there. Okay, so, and then that means that we have to clean this answer as well. All right, so x will go there rather 16. Okay, all right, and then use the 16 here to multiply everything there. So you're going to have 16x minus 32. Okay, now this is very correct. All right, so that means that s cubed plus 6x squared minus 32 equals 0 could be written as x minus 2 into one bracket, x squared plus 8x plus 16 into one more bracket. Okay, and that would mean that the first one, this is equal to 0, or the quadratic is equal to 0. All right, so that means this gives us x equals to 16 factors of 16 added, that gives 8 is 4 and 4. So you have x plus 4 and then x plus 4 equals 0. This means x equals 4. Therefore, the roots are x equals 2, x equals 4. Okay. But you can use your calculator to verify everything out. That's also allowed. Actually, it's x equals negative 4. Because it's positive, so it crosses the equal to sign to become negative 4. Yeah. Okay. So negative 4. All right. So let's move on. It says, give a reason why only one root is a valid solution to this logarithmic equation. All right, so let's see. These are the two logarithmic equations that they gave us. All right, and then you got two x values, positive 2 and negative 4. So let me show you something. X equals 2 and then x equals negative 4. Well, logarithmic functions are functions that take positive values, because a log can't be a negative value. So if I use this negative 4 into this equation, I'm going to get log of negative 2 to the base 2, and that will be math error if you put it on a calculator. It's undefined. So that is why we can only use this x equals 2 and we'll never use this x equals -4, because the log of a negative value does not exist. Okay, so that's the what you would write here. That's the reason you will give. Then they say find the value of the corresponding y to this root. Well, the root that is correct is x equals 2. So if you want the y value, use one of the equations we got. We can use this equation. This is better. Let me copy it. And paste it here. Okay, so we said that x is 2, so we are going to have 2 plus 2 over 4, giving us y value of 1. So this is also a 2020 paper. Then we have sketched the graph of y equals ln x. So, well, this is pretty simple to sketch. It is going to be asymptotic to the y-axis. Okay, so it is going to look like that. Then the next thing is that you need to find the x-intercept. At that point, y is 0, so x equals 0, right? You can raise everything e, okay? So x is equal to e to the power 0, which is what, 1, so this is 1. Now you've sketched it. Call it y equals ln x for 2 marks. We're done sketching. And the next thing that they are asking you to do is to determine the equation of the straight line. You want a straight line that will be needed, which would need to be drawn on the graph of y equals x in order to obtain a graphical solution to this. Okay, so what you really want to do is to take this part of it and try to get a straight line from that equation. So you have x squared e to the power x minus 2 equals 1. Well, you can decide to take the natural log of both sides, which is the ln of x squared e to the power x minus 2 equals the ln of 1. Now, let me show you something. Ln 1 is 0, so ln 1, right, on the calculator, you say ln 1. Calculator will tell you that the answer is what? Is 0. Okay, so we can write ln of x squared. Okay, let me even expand that straight away. So you have ln x squared plus ln e x minus 2, everything equals 0. So this gives you 2 ln x squared plus x minus 2 equals 0. So we can have let's see, let me put the x together. Oh wait, you see something here. It's equal to 2 minus x, right? Good, and I'm going to divide both sides by 2, so I'm going to have this, which is the same as 1 minus half x. Okay, but why did I do that? Why did I make ln x the subject? So it's like I have ln x is equal to 1 minus half x. Why did I do this? Well, if you check the equation that was given, they asked you to sketch the graph of this. And if you are sketching two things, this and that graphically, you want to have a solution, then you should have a situation whereby the two curves will cross themselves. And if they will cross themselves, then from here, y equals ln x. Okay, so the second one, I want to make ln x the subject, so that even if I want to solve it algebraically, I can equate ln x to ln x and solve for the value of x. So that is the main reason why we make ln x the subject. But the question is not really asking you to determine the solution. They just want you to determine what? The equation of the straight line. So you say that this is the equation of the straight line. 1 minus half x. All right. Now the next thing that you want to do is to find the product of this and that. Okay. So you have a to the power 1 over 3 plus b to the power 2 over 3 is going to multiply a to the power 2 over 3 minus a to the power 1/3 b to the power 2 over 3 plus b to the power 4 over 3. Okay, so now what we are going to do is that a to the power 1/3 multiplies a to the power 2 over 3. You apply the laws of indices, so you add the powers. You are going to have the power of 1, which is just a. Now, the next thing we want to do is a to the power 1/3 times this a to the power 1 over 3. You apply the laws of indices, so you are going to have a to the power 2 over 3, b to the power 2 over 3. And then you are going to use this to multiply the last one. You are going to have plus a to the power 1 over 3, b to the power 4 over 3. Then use this b to the power 2 over 3, distribute over the entire thing. You're going to have plus a to the power 2 over 3, b to the power 2 over 3. Now use this, multiply that. We're going to have negative a to the power 1/3, b to the power 4 over 3. And then finally, this times that will give you b to the power 6 over 3, which is b to the power 2, right? So let me just clean this and write 2. Okay, so when we finish, some things are there for us to cancel. Check this one out. This is a to the power 2/3, b to the power 2/3, a to the power 2/3, b to the power 2/3. This is negative, this is positive, so they cancel out. Also, check this one out. You have a to the power 1/3, b to the power 3 over 4, 4 over 3, and then this is also a to the power 1/3, b to the power 4 over 3. This is positive, that is negative, they cancel out. So your answer is a minus b squared. Okay, this is it. Okay, then the next thing that happens is that they want you to evaluate something like that. Okay, so basically you have some 5s and 2s and things here, and 10 is 2 times 5, right? All to the power of x. So you want to have something of this sort. Okay, 2 times 5 in one bracket to the power 10. So what you want to do is to manipulate the left this particular thing till you get something like this. Okay, so let's do that. Let's manipulate it. We are going to employ everything we know, every indices, everything we know in mathematics to do that. So if I start from here, I can write 2x times 2, right? It's not dot, it's times. And I have times 5x times 5 to the power negative 1. Do you agree? Yeah. Then I have 2 to the power 3x dot 5 to the power 2x. Okay, now check this now. I have 2 to the power x here. I have 2 to the power 3x, but I just want 1x, so I'll rather divide both sides by 2 to the power 2x. Okay, divide 2 to the power 2x, 2 to the power 2x. So what happens is that this will cancel out with that, so I'm left with 2 over 5. Okay, since this particular thing is 5 to the power negative 1, so it goes down there. Now you multiply that by 5 to the power x. Also on this side it will simplify to 2 to the power x, right? So 2 to the power x times 5 to the power 2x, right? Okay, now if you check what we have here is only x, but we have 5 having what, 2x. So why don't we divide 3 by what, 5 to the power x? So I'll do that. So I divide this side by 5 to the power x, and divide that side by 5 to the power x, and then this side and that side will cancel out. What you have is that this takes one of that. So that means you have I skipped anything out? No. Oh yeah. Okay, so I'm going to have, wait, oh yeah, sure, check this thing out. When you expand, this is square. Okay, so this is square. So 2 squared, that's 4, okay, over 5, because I felt like I've left something out. Okay, and then this is 2 to the power x times 5 to the power x. You can factor out the power, so you are going to have 2 times 5 all to the power x. And this is what 10 to the power x gives. So the value of 10 to the power x is basically 4 over 5. So this is how to solve a question like this. It's not very common, but it comes. So you should, know this. Well, like I said, I'll solve till I'm tired, and I'm already getting tired. So let's see. Okay, let me solve that question, and then maybe solve 1 or 2 more, and then we call it a day. Now, whenever you see a question like this, it should ring a quadratic to you. Okay, why? Because there's some square here, and this doesn't have a square, right? But if you don't see it that way, let me prove it to you. This part, we can rewrite it as 3x all squared, right? Then we have minus 3x plus 1 minus 4 equals 0. We can split this part as well. So we have 3 to the power x all squared minus 3x times 3 minus 4 equals 0. So you can say let y be equal to 3 to the power x. So you're going to have y squared minus 3y minus 4 equals 0. Now do you see that as a quadratic? Yeah. So once you see something of this nature, start to think of quadratic. I'm just going to use the calculator to solve it. You should be able to solve it. And in the exam, you are supposed to solve this. Don't use a calculator to do that. They will award marks for that. Okay, so you have y equals 4 or y equals negative 1. Okay, but you know, the question never came with y. We brought y. The question came with an x. So you remember this definition we gave? Yeah, we got to use it again. So we said 3x equals y. So when y equals 4, we are going to have 3x equals 4. Take the log of both sides. So log this equals log that. So x is equal to log 4 over log 3. They said find the exact solution. So don't put it on the calculator. Leave it like that. Also, when y equals negative 1, you are going to have 3x equals negative 1. Now, you can't solve this. Why? Because if you take the log of both sides, let's practice and see. You have x log 3 equals log negative 1. Log of a negative value, ladies and gentlemen, does not exist. So this has no solution. Okay? So the answer that the marking scheme will be looking for is just when x equals this. You are done. All right. Okay. Let's look at this case. So now we want to solve something like that. So you can just take the length of both sides. It's easier that way. Okay, is equal to length 3, that guy. Okay, you know the rule already. This becomes 2x plus 1. Now I want you to expand this bracket, apply the laws of logarithm on it. So you have length 3 plus length e to the power 4 minus 3x. So you have 2x plus 1 equals length 3 plus 4 minus 3x. Put the x's together, so you have 5x. Now you have this plus 3, I think so. So x is length 3 plus 3 over 5. Okay, this is solve for x, so you can put it on the calculator and then you get the value. Yeah, I think I've not made any mistake there. But if there is, you can identify it, correct it, also put it right in the comments below so that your friends can also find it. So 3SF is 0.819 what? Let me just write 0.8203 SF, I think so. Now you have this equation to solve. This a log, so for 5 marks. So that becomes they are adding, so we go to multiply. Okay, so you have log this, that, this, and that. Okay, is equal to 2, but these logs, all right, come with base 10. So that idea, I'll just write log 10. Okay, because log 10 base 10 is 1, so I haven't changed anything. I'm going to have y square. Okay, log y square 15y minus xy minus 90. Then I have log 10 squared. That's about 100, right? Yeah. So if this and that are the same, then this will be equal to that. So you have y square minus 9. No, it's actually plus 9. Y minus 90 equals 100. So we are going to have y squared plus 9y minus 190 equals 100. Y will be equal to what? I'm going to use calculator to do that in exam. Solve it. So you have y equals 10 and then y equals negative 19. Okay, then you are done for 5 marks. Now they will ask you to solve, so solve it. Is there anything difficult that we should solve? If not, then I'll end it here. Okay, there is a change of base here, so I think we should solve that. And then yeah, so let me solve this as the last question for the day. The rest, just go and solve it, okay, and compare the answers to the scheme. Show that log 4 base 9 is the same as log 2 base 3. Well, what is the base here? That's 3, okay? So that's about 3 there. So what I want you to do is to change log 4 base 9 to the base 3, okay? So you have log 4 base 3 over log 9 base 3. But you know 9 is a perfect square, so you can write it as, let me keep this as that. You have log 3 square base 3, and that will give you base 3 over, that should be 2. Okay, now what else is missing? We are not getting that, are we? No. Okay, now 4 is also 2 square, so you can write log 2 square base 3 all over 2. The 2 will go back, so you have 2 log 2 base 3 over 2. 2 cancel out, and then we get what they wanted us to get. Okay, and that's the answer. Okay, so you apply everything you know, but be careful. You have this and that and this. The bases are the same. This one is base 9. This is base 3. So be careful. But you have already solved this, haven't you? You got this. So just put it there. Don't start afresh. You solve this. You got that. Use it. So you have log 2 base 3 plus log x base 3 equals 3. Okay, since they are adding with the same base, they come to multiply. So you have 2x base 3 equals log 3. You want to do 3 base 3 because the basis in this case is base 3. So you have log 2x base 3 is equal to log 3 to the power 3 base 3. Okay, now if this is equal to that, then this must be equal to that. So you have 2x is equal to 27. X is 27 over 2. Well, you can leave it like that, or you can just put 27 over 2 on a calculator That should give you 13.5. Yeah, 13.5. Okay, and that is it. I think the rest is nothing difficult. Nothing difficult. Nothing difficult. Well, this seems a little bit interesting. Okay, for real, this is the last one I'm doing. You have something like that, so just why not take the log of both sides. So you have log 2, 3, this guy equals log 6. So you have 3x 3x minus 1 log 2 is equal to what else can we do? Log 6, can we split log 6 as that? Will that work? Yeah, let's see. I want to put this in a bracket before it confuses us. So that will be log 2 plus log 3. If I do it this way, basically, how am I helping myself? Let me just clean it. It doesn't help. I'll just put, I'll just put log 6 here. I think I was just trying to complicate issues. Then I divide through by log what? 2. So I'll take, I have 3x equals log 6 over log 2 minus 1. Okay, then I'll divide the whole thing by 3. So I'm going to have x is equal to log 6 minus log 2 minus 1, all divided by 3. Or I can just say 1/3 times that. I think that is cleaner. So since they didn't say that, leave your answer in the exact form, you need to put it on the calculator. And then let's see, 1/3 times log 6 over log 2 minus 1. Yeah, and then calculator says I get 0.528. Okay, I can cross-check that. And then I have this. Well, check here. There's a base of y, base of 3. Bad news. Change all to the same base. Okay. So let me work on this one first. Let me change it to base 3. So 2 divided by log 3 base y. So let's change that. So we'll get log 3 base 3 over log y base 3. And that will give us 2 divided by 1 over log y base 3. That will become 2 times log y base 3. Okay, so this is what we are going to have. Okay, so like now we can copy this guy and go and use it. Let's put this somewhere here. Okay, then we can clean all this. I need a space to work out. I don't want to be scrolling up and down. Okay, then so let's work out. We have log y plus 14 base 3 equals 1. That one, I'll make it log 3 base 3 over plus, then we have log 2 log this guy base 3. So I'll have this y 14 3 equals log 3 plus log y square base 3. I think I can put the 2 together since they are adding. So that will become log 3y square base 3. Since this is equal to that, this will be equal to that. So we have y plus 14 equals 3y square. So you can have 3y square minus y minus 14 equals 0. If I use the calculator, of which you must not do that, you must solve it. You get y is equal to 7 over 3, or y is negative 2. So you know that they want us to solve for y. So we are done actually. You don't have to think too much, you are done. So that's how to solve a question like that. I will end here. Now there are so many questions here that I think you should solve. Well, if there's a problem, you can comment there and I'll help you with the solution. Okay, so we meet again. Take care of yourself. See you around. Bye.